Okay, these are great. Find the values of x and y at in this parallelogram PQRS. So let's see, they're telling us, let's first write what we know for the first one, because 14 and 15 are different. They're telling us that PT is 2x and TR is y plus 4. We know they're equal, but that has two variables. And that would be problematic if we can only write one equation. But we also know that QT is equal to x plus 2 and TS is equal to y. And because we have two separate equations, we are actually able to use systems of equations to solve. So let me write this first one out. I'm going to zoom this in a little bit so I can write a little bit smaller when we shrink it out. So let me zoom in right here. And let's say that this is for 14. We can say, if we can say x plus 2 equals y and 2x equals y plus 4, then you can see over here that we know what y is equal to. It's equal to x plus 2. So we can put that in where y is here. Substitution. This is just a really powerful method for solving equals. And hopefully you're seeing like, yeah, it's a really valuable thing. Okay, so instead of y, we're going to write x plus 2. It's y's equivalent, x plus 2. And then when we simplify that out, we get 2x equals x plus 6. Subtracting x from both sides, we get x equals 6. And then when we sub that back in to the equation over here, what plus 2 equals y? Well, we know that x is 6. We can say 6 plus 2 equals y. And then therefore 8 equals y. And you've found that. That's our solution for 14. Let me zoom back out. Oh, hold on a second. Okay, so for number 14, we've got y equals 8, x equals 6, and let's do it again. Let's do it again for the other one. I'm going to take the same figure. Let's see if I can grab this figure. I'm not sure if I can. Not the way that I want to. So I'm going to redraw it over here. Hopefully, actually, let me just do it. Okay, and we're going to do the same thing. We're going to just fill it in again. We know that PT is equal to x plus 2, and we know that TR is y. We also know that QT is 2x, and TS is y plus 3. So I'm going to zoom in on this, and we're going to solve this here. We can write this set of equations here. We can say 2x equals 3y. They must be equal if it's a parallelogram. And x plus 2 equals y. That's number 15. So we know, we're just looking at this, we know what y is equal to. Y here is equal to x plus 2. So let's write it over here. We could say 2x equals 3 times whatever y is from the other equation, and y is equal to x plus 2 in the other equation. So we're going to simplify it. 2x equals 3x plus 6. And if we subtract away 3x, we get negative x equals 6, which means x equals negative 6. This seems a little funny to me. Can I just check this out a second? Let me zoom out. See if I did that right. Y plus 3, 2x, x plus 2, here is y. Yeah. course. Why did I do that? I bet you saw my mistake and you were like, no, Massey, no. So sorry. This is not 3y. This is y plus 3. So when I do that better this time, my mistake for making you sit through my error, but hey, as you can see, teachers make errors too. The reason that I knew this was a mistake, and I just highlight it, is x is -6. That in and of itself is not a problem, but if I plugged it in and I got -6 plus 2, that's -4. I can't have -4 length. It doesn't make any sense. So right away I'm like, what? That was the problem. So let's fix that error, my mistake. Y plus 3. And I need to erase all this nonsense at the bottom as well. So just a second. Wow. It's a little late in the day, sorry. Happens to the best of us. Not saying I'm the best of us, but you know. So we know that y is equal to x plus 2. So we're going to say parentheses plus 3, and we're going to fill that in with an x plus 2. And then we're going to get x plus 5 is equal to 2x. That makes more sense because when I subtract the x from both sides, I get x is equal to 5. I feel more comfortable with that answer. And then over here, we're going to write parentheses, whatever x is, plus 2 equals y. We had an equation here in 2 variables, couldn't solve it. But we now, because this is not varying anymore, we've nailed it down to a value of 5. It's no longer an equation in 2 variables. It'll now become an equation in 1 variable. And now we can solve that. We get 7 equals y. So x is 5, 7 is y. We'll shrink this down, check it out. And those are our 2 solutions. I'm sorry for the mistake there, but I guess that highlights something important, which is if you ever end up with a value that gives you a negative length, you should recognize that, oh, what's that about? There must be an error somewhere. So yeah, if something seems funny, sometimes you might not know what it is, but puzzle it out. Don't just be okay with it being funny because it might actually be problematic and you need to sort out what it is. Anyway, hope that helps.